guest lecturer from University of Taipei. Here is Professor Chia-Hua, and he is the foremost distinguished professor in Taiwan. And here is curriculum vitae of Professor Kuo. He's the Dean College of Kinesiology, and his education got PhD in University of Texas at Austin. And now he's so many publication, and he have each index of Scopus 28, so it's higher, and publication more than 300 paper. Before we are going to the professor lecture, maybe we'll have some welcome speech from Professor Sugianto. Professor Sugianto. Okay, so now the time is yours.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Honorable Mr. Chia-Hua, PhD from University of Taiwan, Taipei, Taiwan. Rector of Semarang State University of Ornate Services, Director of Postgraduate Semarang State University, Ornate Represent, and also fellow students, ladies and gentlemen. First of all, I would like to welcome our excellent speaker, Mr. Chia-Hua, as a guest lecturer in this prestigious meeting. We are very happy to present Mr. Chia-Hua in this event to discuss about teaching and learning, especially sport physiology course with students of postgraduate Semarang State University all participants. Semarang State University is making various efforts to prepare itself in order to create a world-class university. This effort helps to increase the quality of the learning process, provides experience for students with foreign lecture, and an international insight for students, networking for UNNES lecture. But in the field of education and research, as well as community service. I hope this effort can be continued in the future, and I believe that the result of this effort can open our mind and add international insight and network for participants. Finally, I would like to say, happy joining this meeting. Cap spirit, thank you. Okay, Mr. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Professor Sugianto. And now, stem cell is very popular in research, and now we need to learn how is the how to say how the effect stem cell on human and after exercise. And Professor Chia-Hua very how to very active to study about stem cell. Now we would like to hear him presentation about the stem cell. Okay, welcome, Professor Wu.
Okay, I would like to thank you for the greeting from the Professor Suryando, and also the invitation from Titin, my old friend. Okay, today I'm going to cover the topic is related to sports nutrition and immunology, entitled "The Stem Cell Aging in Human Muscle Reversed by Exercise." So from the title, you already know the answer, right? The exercise is going to reverse the stem cell aging in human skeletal muscle. Okay, let me see whether this is working. Okay, I have the conflict of interest statement because some of the presented data is involved with U.S. patent to formulate an ergogenic supplement to kill the aging cell in your body. So that is the new method to improve your sports performance. And that was sponsored by Nordic Taiwan and USA and Ministry of Science and Technology in Taiwan and University of Taipei. Okay, the message here, the first one I would like to give you very important knowledge that is involving with the COVID-19. If you inject, the stem cell is produced from bone marrow, okay? And those stem cells, some of the stem cell can be used to regenerate tissues, and some of the stem cell can use to produce immune cell, which will clear the aging cell in your tissues, okay? So bone marrow is very important, okay? So if you have sufficient amount of the cell produced from bone marrow, you will be able to constantly remove your senescent cell in your tissues surrounding the bone. And also you have the stem cell to regenerate the tissues. The problem is if you do a very simple experiment, you inject the stem cell into your blood vessel, and you will see about 60 to 70% of the stem cell is going to the lung, okay? And very few go to skeletal muscle, okay? So under resting condition, most of the stem cell is consumed by the lung, okay? And therefore, if you understand that COVID-19 is pneumonia, right? Pneumonia is going to have the higher demand for the stem cell to replace your infected alveolar, right? The lung has the cell got infected. If you have enough immune system, you'll be able to kill those infected cells and renew your lung cell. So it's quite important to have sufficient amount of the bone marrow stem cell. Okay, and what determined that the young people, when they got infected, almost 100%, 99% can survive, right? But what is the reason that the old people cannot survive? The main reason is because you don't have enough bone marrow produced cell to replenish the lung. And that is because of the demand of the rest part of your body. If the rest part of your body, especially the skeletal muscle, if they are aged, if they are old cells in skeletal muscle, they are going to consume a lot of immune cell, and therefore your lung is going to have more difficulty. So that is the most important reason to explain that the reason the aging people would die on COVID-19, but not for the young people. Okay, so you have the resource distribution problem that is very important to keep you survive. Okay, then today's lecture, I will be focused on how do you get your skeletal muscle younger. Okay, so when your skeletal muscle is younger, then your lung is going to have sufficient supply of immune cell, right? So to keep your skeletal muscle younger is the main message I'm going to talk about today. Okay, so the lecture content is why exercise keep you younger. Okay, so you have two conditions to choose. One is you don't challenge your muscle. You're just resting. You don't challenge your muscle, right? And another situation is exercise. Then your muscle is challenged. You found that if you choose the resting condition, you age much faster compared someone who has exercised. Okay, so we are going to explain why. Okay, then I'm going to cover how a multicellular system remove aging cell by exercise. So the answer is actually, I just mentioned that it's mediated by immune system. Okay. Then eventually I'm going to talk about a molecule called ginsenoside RG1, which is a chemical compound that produced from the ginseng. There are many types of ginseng that has the RG1. So I'm not sure about the, we know in the Dian, in the highland in the central Java, Dian, right? They also have something similar. So I'm not sure whether they have the RG1 or not, but you can study for the future. So this ginsenoside is immunostimulant. So that means it would activate the immune system. And we have found that this compound is able to help the muscle rejuvenation if that is used together with exercise. So that means exercise is going to bring the molecule into the exercising muscle, and it would help to clear the aged cell in your skeletal muscle. Okay, so before I get into the scientific data, I would like to explain what is the stem cell aging. Okay, the stem cell aging is featured by increased P16 expression. P16 is a protein that expressed in only in replicable cell. Okay, it would inhibit cell cycle, so it's called cell cycle inhibitor. Okay, so if you look at all stem cell in your body, it's going to express P16. So the aging cells express more. The younger cell express less. Okay, so what if you have a lot of P16 expressed in a stem cell? It is going to help cell regeneration and the cell renewal and the stem cell homing to the damaged tissues. So that means if you have the stem cell that has high amount of P16, then you can consider this stem cell is get into the senescent state. It's aging state. Okay. So you understand that when you have the injury or you have the wound in your tissues, you can quickly heal the wound. Okay. For young people, you can heal the wound in probably 1 day if you have the mosquito bite, right? So if your skin got mosquito bite, then the baby can fix the problem in probably half day. But if you are adult, then you have mosquito bite, then the red dot is going to sustain there for 1 or 2 days. So that gives you the idea that for the people who has higher age, the stem cell also aged, and therefore the stress tolerance and the fitness will decline, simply because it takes a long time for recovery. Okay, so that gives you the idea that you don't want to have the stem cell to express high amount of P16. Okay, so when there's a stem cell has high level of P16, we call it stem cell aging. Okay, so now I would like to give you the mechanism how human body is going to keep their body young. Okay, so what is the mechanism? Okay, if you look at here, you know most of the cell in human body are short-lived. Just give you one example. The stem, you know that. Sorry, let me just fix the computer problem. Okay, I try to move the screen down. It's blocking. Okay, good. Okay.
Maybe you can use the arrow button.
Okay, so now, so when you know the cell in human body, we are multicellular organism, right? The human body has trillions cells in your body, and most of the cell age rapidly. Just give you one example. You know the red blood cell. What is the half-life of the red blood cell? So everybody know, right? The longevity for red blood cell in your body is about 3 months, right? And how about endothelial cell? The endothelial cell in your blood vessel has the longevity only 2 weeks, right? So that means in your body and my body, the cells are continuously aging and die and regenerate, right? So when the red blood cell get into the age of 2 months, they are already unhealthy, right? And when you have the stress, when you have the aging, when you have the infection, those cells are going to stimulate your immune system. So when they stimulate the immune system, the immune cell is going to have phagocytosis and regeneration, and then finally to regenerate the new red blood cell. This process is called inflammation, right? So inflammation is a good thing or bad thing? It's a good thing. It happened at the bad situation, but it's going to clear the unhealthy cell and regenerate the tissues, and therefore you can get it yourself younger. So this is what we call the tissues rejuvenation. Okay, so when you finish the rejuvenation, then the tissues is going to have the low inflammation level. You have a better fitness, and that is going to improve your performance. Okay, so if you look at right here, on the lower left side, these are the tissues, right? And you have a normal cell, looks pink, and you have aged cell, looks blue. Okay, and these blue cells is going to produce a lot of cytokine. And this cytokine is going to attract the immune cell. So immune cell get in and clear the blue cell. These are the senescent cell. And therefore, you can see that you have the new cell regenerated, and then the entire tissues get younger. So you don't want to consider the inflammation is bad things. Okay, the inflammation is very important to regenerate your tissues. And therefore, if you think about why the multicellular system, like a human, are never worried about surgery. You understand when you do surgery, you are going to damage your tissues, right? Because you understand that when you have the surgery, you have the inflammation, and the inflammation is going to bring back your tissues. So you never worry about the surgery. You never worry about damage, right? Because we have the immune system. Okay, so now let's get into the most important question of the lecture, is how exercise is a damaging challenge against aging. Okay. The most important concept that you want to consider is the second law of the thermodynamics. Okay, if you read the second law of the thermodynamics, the entropy increases in spontaneous physical and chemical process. So that means if you have any physical and chemical process, it's going to increase the randomness, right? From order to disorder. So that is the direction of the direction of any order structure is going to be disorder. So you go back and think about human. The human body has a lot of cells, right? And they are put together. And therefore, human are highly ordered structure. So what do you expect on human body if you are high order structure? You know that highly ordered structure is going to become randomness. That is the central, that is the spontaneous process, right? And because of this concept, a lot of people thought that, okay, I understand that exercise is make your body healthy, but I also understand that exercise is going to increase the entropy. And the entropy is going to damage your tissues, right? So what kind of exercise intensity is the best for your health? So if you use the guess, you guess by your mind. So many people, they make the recommendation by intuition. So there are many people, they recommend, okay, you don't exercise, that is not good. But I would say high exercise intensity is not good as well. So you should go moderate exercise. And that kind of intuitive concept is not supported by evidence. So let's look at what evidence looks like. Okay. So in the past, there are more than 30 studies already investigate the relationship between the exercise intensity and human longevity. If you look at the number on the right side, right here, just give you an example right here. You see 300 minutes per week. Okay, so let's assume you can exercise 300 minutes per week. And the number here is the relative risk of death. Okay, so you want the number lower to be lower, right? So lower number means the probability of death is lower, right? 61% right here. And if you look at on the left side, this is 5 different intensity. Okay, so what is the highest level? Vigorous exercise and sports, right? So vigorous exercise and sports. If you do that for 300 minutes per week, the mortality, the chance of death is only 61% compared to sedentary people. Okay, and then you have the moderate, you have walking, you have physical activity for transportation. This is the lowest exercise intensity. And you can see the number is going up. It's 85% chance of death. So this study put together give you the idea that the exercise intensity is positively correlate with human longevity. So you want to do high intensity, although you understand the fact that higher intensity are involved with more physical and chemical process, and that is going to increase your entropy even more, right? Okay, if you look at another study, this is the study that has been done for the age above 50. Okay, so normally people think the age over 50, the fitness level is going down, right? So what is the recommendation for, what is the exercise intensity recommendation for those age above 50? So this has been tested in the past. So there are 2,205 people join the study, and they are participating low, medium, and high physical activity since they are age 50. So 35 years later, when they are age 85, and please look at what is the cumulative total mortality. So you can see which one has the lowest total mortality. You see the high physical activity, right? And this is, if you look at, this is the some of the participant. When they are age 50, they decrease their exercise intensity from high to low or medium because they think I'm getting old and therefore I should adopt low or medium physical activity. But some of the people, the green line, are the participant increase their exercise intensity from low or medium to high. Okay, so let's look at the red line and green line from age 50 to age 85. What happened to the total mortality? You can see there is a crossover here, right? You see, for those people who are increasing exercise intensity, 15 years later, their survival chance, their cumulative mortality are lower, right? So this gives you the idea that it won't be too late to increase your exercise intensity after age 50, okay? So why high intensity exercise give you better longevity benefit? So what is the possibility? And we understand that if you have high intensity, you have a more physical and chemical process going on, and you're going to have more damage, right? So high intensity has more damage, but it has more survival chance. Okay, the hint is right here. You want to consider human are multicellular. So as I have already mentioned, that if you look at yourself, every single cell are life, right? So the life, you have the fit cell, you have unfit cell, right? And you have the younger cell, you have older cell, right? So in your body, you have two different fractions. You have young cell and your age cell. So let's assume I give you a challenge. Who is going to die? Young cell or age cell? Who are going to die if I give you a challenge? The old cell is going to die, right? Because most of the old cell, they cannot sustain challenge and therefore die. The young cell are going to survive, right? And what would happen when the old cell is going to die? Information would be triggered, right? The information is go after the age cell and clear those age cell and triggers regeneration process. And therefore the entire tissue is becoming younger population, right? So that is the mechanism. Okay, let me give you very important concept, which is very important for you to set the grand strategy for yourself, because you understand that humans are multicellular, right? Okay, if you look at the yeast, you know the yeast, right? You know when you're making bread, you're going to need yeast, right? This is how yeast looks like. And you see the yeast right here? It looks like a single cellular, it's a unicellular system, right? But if you look at some of the yeast, they are able to make friends together, okay? Especially when the yeast is having baby right here, right? When the yeast are having baby and they work together and they are going to form a multicellular system. So if you look at the yeast population, you can see two kinds of population. One is the yeast, they survive by their own. And you also see the yeast are able to make the family or make a friend, okay? So you have unicellular yeast and you have multicellular yeast. So if I ask you the question, what kind of yeast has better survival chance? Okay, the answer is right here. Okay, so this is the experiment, test the hypothesis that multicellular yeast has better survival chance. But the problem is not exactly like that. If you look at the way they make the challenge is they put the yeast into a centrifugation. So if you have the gravity, some of the yeast cannot survive, right? Okay, so if you look at the yeast with centrifugation and you have the multicellular yeast and you have the unicellular yeast, which one is going to have higher survival fitness? The multicellular, right? The black one is the multicellular, higher fitness compared with the unicellular. But if you have no challenge, then you will see multicellular and unicellular has about equal chance to survive, right? So that gives you the idea. We are human and we are multicellular. And the reason we are multicellular is because if we're living in a challenging environment, we are better survivor, right? And that is under the assumption that the environment is giving us challenge, okay? So that gives you the idea that multicellular system has an advantage only when they are living in a challenging environment, okay? And why challenge is important for your survival as a multicellular system, we already mentioned, because we have the information mechanism. Okay, so let me give you another very important observation right here. So this is the yeast, which can form a multicellular system. And you can see the cell number are getting more and more and more and more. Only 300 minutes, you can see the cell number increase dramatically and forming a big multicellular system. And when it is too big, the physical stability is going to be undermined, right? And the way to solve the problem is having baby. So you separate, you have baby, right? And therefore the problem is solved. But what if you are continuously getting bigger? So let's look at right here. So this is the grade you want to pay a big attention. If you look at the y-axis, the cell apoptotic means the cell is going to age and die, right? And the cluster area means how many cells do you have, okay? So if you look at the cell, most of the cell cluster are small. But when they are growing bigger and bigger to a certain extent, what would happen? So if you are multicellular, if you are baby, you have a much less cell, right? But when you are adult, your size, your cell number is going to be very high. And what happened is your cell, aging cell, and dead cell in your body is going to increase from 0 to about 2 to 3, right? So this gives you the idea that the multicellular system tend to grow in cell number. But as you are growing bigger and bigger, the problem happens. The disadvantage is the cell senescence and the cell death in your body is going to increase, right? And you understand that if you are growing bigger and bigger and you have more cell death, it's going to demand a lot of immune system, right? And therefore your entire body is going to have inflammation, and that is going to eaten up your immune system. So that also explains the reason why obese people, when they have the COVID-19 infection, they cannot survive well, right? So the aging people and obese people, they cannot survive well because the immune system is distracted by the entire body. And therefore, when you have the challenge to your lung, when you have pneumonia, it's less likely to recover because you are not going to have sufficient amount of immune system. Okay, so let's go back to the hypothesis we are going to talk about. Okay, so we have the multicellular organism. Our hypothesis is that the multicellular organism need physical challenge to kill the unfit old cell and therefore decrease the average cell age of the body in a Darwinian nature selection fashion. Okay, so that is our hypothesis. Okay, then we get into the part 2. How a multicellular system removes unfit aging cells. We already mentioned the immune system, right? So if you look at the right side, this is the main player of the immune system during inflammation. It's called CD68 phagocyte. Okay, the CD68 positive phagocyte is the cell very big, right? And these are the unhealthy cell. The unhealthy cell could be due to age, could be due to infection, and it could be due to stress. They become unhealthy, and those unhealthy cells will be recognized by the phagocyte, and they engulfed and then killed inside the cell. Okay, this is how our body to remove the aging cell. Okay, so this is the experiment that has been done in 1975. So what they have done is they fractionated human red blood cell into old and young fraction. And they put the phagocyte into the tube. And they found that the young red blood cell, YRBC means young red blood cell. Okay. And the ORBC means old red blood cell. Okay. So when they put the phagocyte together with young RBC and the old RBC, you can see the phagocytosis is going to increase, right? But it's selectively higher in the old red blood cell, right? So this gives you the idea that the phagocyte in your immune system only kill 5% of your young cell, but it will kill about 7 times more of old RBC. Okay, so your immune system are able to look around your body and selectively kill the senescent cell.
Karjadi Tirta, maybe you have some action, maybe, Mr. Karjadi Tirta? Mr. Karjadi Tirta. I have turned off your microphone twice, and
we may need to mute.
I have activated the microphone for the.
We may need to mute.
Yes, I have muted twice, sir. But he's still open his microphone, so maybe he want to asking something, so I asking to him.
Okay. All right. Okay. Yeah, so I will keep going, right? So we're going to put the Q&A later, okay? Okay, so now you learn that phagocytosis is very important for phagocyte. Phagocyte looks like this. Okay, the phagocyte are able to look at the unhealthy cell. So this is the phagocyte neutrophil, right? So are able to look around your body and remove your senescent cell, right? But the problem is the phagocyte in your body are short-lived. The longevity for phagocyte are very, very short, about 1 day, okay? So if you are not challenged, the phagocyte is 72 hours. But if you are challenged, the phagocyte can only survive within a day. So they are dying and regenerating all the time in your body. So that gives you the concept that phagocytes are demand cell proliferation. So if you want your tissues younger, then you need to have sufficient generation of the phagocyte. And that is going to demand a lot of cell proliferation. Okay, so if you stop the cell proliferation in your body, what will happen? Then the phagocyte is going to be the number is going to be dropping down, right? When your body has the phagocyte number dropping down, then you cannot clear your senescent cell. And then your body is going to be aging much faster. Okay, so let me give you the experiment right here. This is the experiment that we have done in many years ago. It was published in 2017. Okay, so we block the cell proliferation by using a chemotherapy agent. It's called doxorubicin. You see the DOX right here? This is doxorubicin, which would inhibit cell proliferation. Okay, then we exercise the muscle. So if you look at the muscle right here, this is before exercise, And this is after exercise, okay? And these are before and after exercise, when you block the cell proliferation. Okay, so you block your cell proliferation. You do not see the cell infiltration into your muscle. So when you challenge the muscle, you have the phagocyte infiltrate into your skeletal muscle, right? You see the red dot is the phagocyte. Okay, but if you block the cell proliferation, you do not see the phagocyte get into the muscle, right? Okay, so which situation is better for you? Okay, if you ask the pathologist, they are going to say, okay, you have the red leukocyte get into your exercise muscle. So that means the muscle has something bad happen, right? So they are going to tell you, okay, this is not good. But the problem is, if you block the cell proliferation, you see, this looks good, right? Okay, if you look at the muscle size, okay, let me look at the muscle size. If you challenge the muscle will grow bigger, right? But if you block the cell proliferation, the cell proliferation is blocked, the cell mass, muscle mass is going to be down, right? So this gives you the idea that we are multicellular, right? And the muscle has a lot of cell, right? If you block the inflammation by inhibiting the cell proliferation, the muscle is not growing, and instead muscle are shrinking, right? So now you also understand, if you challenge your muscle is going to get bigger and bigger, right? And the reason you are getting bigger and bigger is because of the inflammation. And the reason you have the inflammation is because exercise is going to attract the phagocyte infiltration into your muscle tissues. And they are going to renew the muscle tissues. And therefore you have a younger muscle cell population, and therefore you can grow. So the muscle is going to grow bigger and bigger, right? How about the survival percentage? If you block the cell proliferation for 40 days, 100% of the animal would die, right? So this gives you the idea that if you don't allow your body to produce phagocyte, your body is going to age rapidly and it's going to die, right? So that explains that you see a lot of cancer patient, right? The cancer patient, the physician is going to tell you, okay, you have a cancer, and therefore you want to, the cancer is going to grow, and therefore you want to block the cell proliferation. But the cancer patient, when they have the doxorubicin for 11 times, no one can survive. Okay, so chemotherapy is very bad things for a multicellular system. Okay, so the purpose I'm going to give you this scientific data is just to give you the idea that when you see phagocyte infiltrated into your tissues, that means that something bad happened, right? But the outcome is going to be good, because that challenge is going to cause the muscle renewal, and therefore you're going to get a younger muscle population. Okay, so let me give you the concluding remark for the part 1 and part 2. Okay, so inflammation is a cell renewal mechanism in living multicellular organism. And keep in mind, the human is multicellular, right? And during muscle inflammation, the macrophage phagocyte is going to invade into damaged tissues, right? And you have the early invading phagocytic macrophage and reach the highest concentration in about 1 day, and followed by regeneration. The generation is called M2 macrophage. It's going to distribute it near the regenerating fiber for several days, and therefore you can have the regeneration going on. So exercise-induced muscle inflammation is inhibited by blocking cell proliferation. So you don't want to block the cell proliferation when you exercise. You want to promote the cell proliferation. The muscle mass is dynamically maintained by a balance of cell death and regeneration. So you don't want to block the cell proliferation, okay? So inflammation is crucial for muscle regeneration and hypertrophy after physical challenge, okay? And exercise is going to induce inflammation in your body. Okay, so let me get into the part 3. Okay, so we understand the mechanism, and now we want to prove the concept that if you are able to activate your immune cell, okay, before exercise, then you are going to strengthen the immune power to clear the senescent cell in your muscle tissues. So that is the concept. We want to prove the concept is true. And we know that the immunostimulant RG1 from ginseng is already known, which can activate the phagocytic macrophage. And it can also activate the CD4 lymphocyte. Okay, so what we have done is we ingest the RG1, and then we start to exercise to bring those chemical compounds into your exercising muscle tissues. So this is how we design the experiment. So I'm also give you the background that how do you identify the senescent cell in your tissues. Okay, all senescent cell in your body is going to express these 2 markers. The first marker is called P16, which is the stem cell aging marker. Okay, so it only expressed in the stem cell. So when the stem cell are aged, you are going to have the P16 positive. You're going to have the P16 expression. Another marker is called beta-galactosidase, which is a lysosomal protein. So when your cell is getting bigger, your lysosome is also getting bigger. And the beta-galactosidase is a lysosome marker, so it will get bigger. Okay, so these are the aging cell marker we call senescent cellular senescence marker. Okay, and this is the proof of concept that if you use the P16 messenger RNA, if you get the messenger RNA from the lymphocyte, and this is the age from 18 to age 80, you can see the P16 number, P16 mRNA there's a linear relationship between the P16 expression and the age. So this has proof that if you are human and you're getting older and older, you can see the cell is going to express the P16 more and more over time. Okay, so we asked the question, if you exercise, what will happen to your senescent cell in human muscle? So these are the experiments we have done in 3 years ago. And it was published in 2018. So this is the human muscle cross-section. So keep in mind that this the subject, the participant of the experiment is age only 21. Okay, we understand age 21 are quite young, right? But when you get their muscle out and then you stem with the P16, you found that those young people already have the age cell in their muscle. And we further extend the muscle, we found that those muscles are co-localized with the endothelial progenitor cell. So endothelial progenitor cell is the stem cell which is able to regenerate your capillary, your blood vessel. Okay, so we understand that those stem cells can also age in the young people. Okay, and what happened after exercise? Okay, if you look at this is P16 level in the muscle. Immediately after resistant exercise, those aging muscle number is declining by almost 50%. And this low level can sustain for 48 hours. Okay. So this study demonstrates that if you never train yourself, your muscle is going to have the aging cell, senescent cell, and just one bout of resistant exercise is going to lower your senescent cell number in your muscle tissues. So we prove our concept. And we also found that after exercise, you can see a lot of leukocytes infiltrated into the damaged muscle. So this phagocyte is going to clear the unhealthy cell. So you can see about 3 times increase in the leukocyte. And if you have low concentration, if you are giving low protein, it's going to give you more leukocyte infiltration into the tissues. Okay. And these are the CD68 positive cell. It's 40 hours later, it's increasing. Okay. So we identify that if you are young, if you are a young human, if you look at your blood vessel, you can already see the endothelial progenitor cell are aged surrounding your capillary. And the endothelial progenitor cell are very important to replace the endothelial cell. Okay, so if you have the endothelial cell in the capillary which is damaged or aged, you are always require the endothelial progenitor cell to replace those aging cells. Okay. So this is another study also published about the same time as our study. It also showed that resistant training can reduce the senescent cell P16 cell number by about half. Okay, so we have 2 labs in the world that demonstrate the same thing, that the aging cells are localized surrounding the myofiber, and the resistant exercise is going to kill those senescent cells. Okay, so these are the resistant exercise. Okay, RT, resistant exercise. How about aerobic exercise? So if you ask the question, everybody here are the expert in exercise, right? So you understand resistant exercise and aerobic exercise. Which one is going to give you more muscle damage? Resistant, right? Resistant exercise is going to give you more muscle damage. Okay. Then we are going to try aerobic exercise. So we asked the question whether aerobic exercise is going to reduce your senescent cell number. And the answer is, if you just count cell number, you do not see the decrease. So this is the if you look at the brown spot right here, is representing the senescent cell. You can see before, after, then the brown positive cell number doesn't change much. But if you are taking the immunostimulant, RG1, before exercise, then you see the senescent cell number is largely cleared. Okay, so if you are doing the exercise that does not induce too much muscle damage, no problem. You stimulate your immune system, make your immune system more sensitive, then bring them into your skeletal muscle. Then you can still eliminate the senescent cell in your muscle tissues. Okay, so let's look at the cell infiltration. Aerobic exercise can also bring leukocyte into your skeletal muscle, but it does not necessarily activate your immune system, right? You need to have the RG1. Okay, let me jump this. Okay, how about endurance performance? So if you have the immunostimulant, which can remove your senescent cell in your muscle, it also increases the endurance performance, right? So this is the improvement of the endurance performance in 12 participants. So the one you have the RG1 is on the top, and the one has the placebo is at the bottom, right? So you can see that if you have the RG1, the improvement is positive. And if you have the placebo, then most of them are, is not changed, right? So this demonstrates that RG1 is going to improve your endurance performance. Okay, so now we have the way to remove the senescent cell, which is increased exercise intensity, and that would damage your muscle, but nevertheless, it's going to make your muscle population younger because we are multicellular, right? So let's go back, think about longevity. Okay, if you are a multicellular system, then the cell number in your body is very important, right? We understand the advantage to be a multicellular, but we also understand the disadvantage of to be a multicellular, right? So you don't want to grow bigger and bigger. If you grow bigger and bigger, then your body start to accumulate the senescent cell, and they are going to die, right? So the cell age is very important. How do you maintain the cell age younger? So let's say you are 65 kilograms, I'm 65 kilograms. So we have the same number of cells in your body and my body, right? But if your cell age, your average cell age in your body is lower than me, then you are younger than me, right? So it's not only cell number are important, the cell age are important. And the only way to kill your aged cell is to stimulate your immune system, right? And exercise is one way to do it. Okay, so let's look at here. Okay, let's look at here. Okay, so if we have the study just finished but not yet published. Okay, we have the people who train all the time. So we have guys who are doing weight training every week. Then we ask the question, if you already trained, is your senescent cell number reduced after training still? We understand that trained people tend to have a lower senescent cell, right? But if you are trained people, then you exercise. Does that make your senescent cell further lower. If you look at here, this is the placebo, right? You don't see the senescent cell number change much. The RG1 doesn't change much. Okay, so we understand if you just count cell number, not very sensitive. Okay, we understand that if you challenge your muscle, then your bone marrow is going to release the EPC, the endothelial progenitor cell. The stem cell is going to release into your body. And if you do high intensity exercise, then those stem cells is going to get into your circulation and peak at about 6 hours, and then it will reduce 24 hours later. Then we ask the question, 24 hours later, are those stem cells is going to replacing the senescent cell in your muscle? This is in the blood, right? 24 hours later, the EPC already come back to normal, right? So if I ask the question, 24 hours later, does the EPC going to be in your skeletal muscle? Then if we look at the cell number first, the answer is yes. But how about the senescent cell status? You see, if you measure the P16 mRNA, you see the senescent cell cut into half. Okay, if you compare the RG1 and placebo, the black part, the RG1 are 33% further lower compared to the placebo. So that means if you train yourself all the time, if you are the bodybuilder, if you are taking RG1, you can still lower your senescent cell status by about 1/3. Okay, and we also found that if you look at the MPO is the phagocyte number. Okay, MPO is the phagocyte marker. If you give the RG1, the phagocyte number is going to reduce dramatically compared when you have the placebo. Okay, so that means if you take the RG1 and you exercise your muscle, not only the senescent cell number reduce, but also the phagocyte is going to reduce in your skeletal muscle, right? Because the phagocyte already finished the job and no longer required to stay in your muscle. Your muscle is already being younger 24 hours after exercise, right? So when your muscle is younger, then your muscle does not require for the phagocyte. And therefore the phagocyte can come back to the lung, right? Your lung is breathing all the time, and therefore the lung requires a lot of phagocyte. So you never worry about the COVID-19, right? You can cure your lung, right? Okay, so this is the senescent cell marker. It's localized in the endothelial progenitor cell. So these are the senescent cell, which is co-localized with the endothelial progenitor cell. So this gives you the idea that if you exercise, you can make your muscle younger. And the reason you make your muscle younger is because you replace your endothelial cell into younger population. How about the endothelial cell number? This is the endothelial cell number. You see, you take the placebo, you take the RG1, it's going to double your endothelial progenitor cell. So that means if you exercise by resistant exercise, I'm not only make your endothelial cell progenitor cell younger, I can also increase the number of the endothelial progenitor cell. So that means when you have capillary cell damage, then you can recover in much faster pace. Okay, so this is the take-home message. Endothelial progenitor cell aging occur during young age in men. Okay, endothelial progenitor cell is the vascular stem cell. Okay, it's aging very early. Okay, the EPC aging is going to slow down cell regeneration, cell renewal, and homing for recovery. And therefore, you are going to have a poor fitness, right? The reason you have a good fitness is because you can recover within a short time. Then you can sustain next challenge. So you have a better fitness. Okay, and that is because you have more stem cell and also they are younger. But if you have the EPC aging, the fitness is going down. Okay, the EPC expansion together with decreased cellular senescence in human skeletal muscle 24 hours after an acute bout of squat exercise. So doing squat is one way to increase your stem cell in your muscle. Decreased P16 mRNA level occur in absence of changes in P16 cell number of muscle tissues in trained men. Cell senescence induce inflammation in human tissues. Okay, so pre-exercise RG1 supplementation is able to decrease the MPO mRNA and exert a greater effect size in senescence lowering effect of muscle tissues after exercise. The young and healthy muscle will spare the immune power, and therefore the other tissues can use this immune cell. And therefore you want to do exercise, right? You do exercise, make your entire body younger, and therefore your lung can recover even you are infected by COVID-19. Okay, and this work are the hard work by the graduate student from Jinfu. You know Jinfu, right? You know Dr. Jinfu. He is now teaching in South China Normal University. And you also know Mook, right? Mook is now teaching in Mahidol University in Thailand, right? Okay, the take-home message: exercise rejuvenate your muscle, and RG1 will strengthen the exercise effect. So this concludes my presentation. Sorry about the cell phone. Okay.
Okay.
Any questions?
Okay, it's very interesting topic, Professor Kuo, and this is so many questions. From Denny Agustiningsih from UGM, University
Okay.
Gajah Mada.
Hello, good to see you again.
And also Prof. Dr. Budi Santoso. Okay, you can directly to asking directly, Professor Budi.
Thank you very much.
Yes.
Hi, Professor.
Nice.
Hello.
It's quite nice to hear.
We have difficulty to hear your voice, Mr. Ali Budi Santoso. Please just unplug your microphone. Maybe that is the problem.
Masih dengar.
Well, then hear your voice clearly from here.
Udah bisa dengar?
Dengar, tapi kecil. Nggak apa-apa dengar.
Yeah, it's quite nice to hear about this very interesting topic. I'm practicing now also during my self-isolation in COVID-19 era with the strength training 7 kilogram dumbbells.
Mr. Ali Budi, we still
mungkin dicopot saja Pak.
clearly.
Ininya apa? Mic-nya dicopot aja coba, bisa nggak?
Sekarang
kedengaran.
Kedengaran jelas. Ya.
Okay.
Ya jelas sekarang.
Sebentar. Yang lain dulu dah mungkin ya.
Nggak apa-apa, ini jelas ya.
Oke, sekarang sudah jelas Bapak.
Sudah jelas Prof. Dr. Budi sudah jelas. Okay. So, is it okay, Dr. Budi? Oke. Tadi suaranya jelas, Bapak? Okay, maybe Dr. Budi fixing for sound, and we will jump to Danny question. She asking about some people do exercise since teenager, but the other doing exercise after 50. Is there any different effect of exercise on their muscle cell when they growing old? And the second, are there any parameter that can be observed to determine the senescent cell? Okay. Unmute. Wait. Unmute.
Okay. This is a good question. The most commonly used senescent cell marker is the P16. We call P16 INK4A. But this protein only expressed in stem cell. Okay. And another marker is called beta galactosidase. Okay, the beta galactosidase is expressed in lysosome. So when cell get bigger and bigger, the lysosome, because the lysosome is function to digest the protein inside the cell. And when you have a big cell, the lysosome is also get bigger and bigger. So the beta galactosidase is also another intracellular marker. But according to our experience, the P16 messenger RNA is much sensitive marker compared to all these.
Okay, so P16 marker.
P16 messenger RNA is better than P16 protein.
Okay. So you can ask him directly?
Yeah, can I ask more, Professor Ko? As you stated that P16 mRNA is the good marker, and when we should sampling this P16 mRNA, is it immediately after exercise, or there should be any time we can observe this P16 mRNA?
Okay, that's a good question. If you look at the people who don't exercise, so if I don't exercise, I never exercise, then you take out the blood, and then you spin down, you fractionate the white blood cell. You know, the white blood cell has the DNA, right? And they can replicate. Then you can measure it. But you want to measure by messenger RNA. But when you do that, you can you have to fractionate, because in the blood there are so many cells, including the red blood cell, which is not going to replicate, right? So you can take out your blood, and then you use the flow cytometry. You use the flow cytometer to fractionate the leukocyte, and then you extract the RNA out, and then you use the PCR to measure it. So that is the one way to do it. But you need to have the flow cytometer. So from my lab, we are doing different way. We use the muscle biopsy needle to take the muscle tissues from young men, and we extract the mRNA, and then we measure it. But if you look at the muscle, then the problem is the senescent cell number, the P16 positive cell number, are fluctuating according to your physical activity. So that means if you are sedentary people, it's good marker. But if you train yourself, if you are looking at the senescent cell in the training athlete, then it's going to be fluctuating. So that is my answer.
But the best time is depend on the physical activity.
Exactly. Yes.
Thank you.
Yes.
Very good question. And Dr. Prodi, you already prepare?
Just unmute. Unmute
Hi.
first, Doctor. Unmute first.
Good, yeah. Okay.
Okay.
Can you hear me?
Yes.
Yes.
Nice,
Yes,
clear.
okay.
Hi, Professor Prodi.
Yeah, I'm very lucky. I'm very lucky to hear your lecture.
Thank you.
I just study everything about MSc, endothelial progenitor cells from Professor Kaplan and so on online. And now I can hear just for the first time from an expert doing this research. I'm therefore very lucky today. And I have so many questions, but I think many others would also have a lot of questions to you. My first question is, the mesenchymal stem cells or endothelial progenitor cells you just mentioned today mobilize from the bone marrow going into the circulation and will regenerate and replace every other damaged or senescent cells in different tissues of our bodies, not only in the muscle, in the skeletal muscles. That is my first question. Another question I will then give to you later, I think.
Okay. Yes, I think you are correct. Because you are the expert in mesenchymal stem cell, so you understand that mesenchymal stem cell only localized to the places that has inflammation. Because during the inflammation
or something like that, yeah.
Exactly. Yes. So if you have the damage, the damaged side would release a lot of signal to attract the stem cell homing to the site. But however, we found that if you are able to bring those cells into the muscle, they are not necessarily function to stimulate the senescence clearing mechanism. That is what we found.
When?
If you are doing aerobic exercise, then the muscle damage is less, and therefore you have less clearance of the senescent cell compared with the resistant exercise, which give you more muscle damage.
Therefore, I choose now privately resistance training now. Every 3 days.
It's good for you. Yes, you already know. 3 days, that's true.
Almost 70. I'm almost 70, Professor Kuo.
Really? You look like 40.
Oh, my goodness. Thank you very much.
So that is very good example for everybody that you should do resistant exercise.
And I have to show my biceps and so on.
Yeah, that's good. Yeah.
Okay.
But it's improper here. Okay.
Okay. So any other question? Yes.
Another question.
Yes. Okay. Please.
Yeah. When my skeletal muscles growing in parenthesis, it means when I was at the Royal Free Hospital, it was a PhD student studying the expression of mRNA for actin, myosin, and so on. After exercise of the rats, of course. And then he was from China. He found that the expression of mRNA for the protein synthesis of the skeletal muscles are beginning just on the 4th day. It is also the general basis for the strength training that people should repeat his training again after 3 days of interval, right? When the endothelial progenital cells, and I think also the satellite cells are proliferating as well in the sarcolemma or something like that. They are residing and dormant, right? When it is 3 days or 4 days, according to your data, the optimal growth or synthesis of.
You talk about the satellite cell?
Yes.
The satellite cell.
Satellite cells are the stem cells in the skeletal muscles also, right?
Right. The classical view about the muscle regeneration is that the myofiber regeneration is rely only on satellite cell. Okay.
Yeah, it was classical.
Right. It's classical thinking.
Conservative, yeah.
Right, but later on, after 2000, year 2000, the people start to find very interesting things. They found that the stem cell, we call PAX7 positive cell, is a lot surrounding the myofiber. Okay, and most of the PAX7 positive cell are endothelial progenitor cell.
Oh, yes, I see.
Thank you
for your enlightenment.
and they discover another things. Endothelial progenitor cell, we call myoendothelial progenitor cell. They are not only used for regeneration of the endothelial cell, but also they can donate nucleus to the myofiber. And actually, most of the stem cells surrounding the myofiber is not satellite cell; it's the endothelial progenitor cell.
Yes. Thank you very much. Yeah.
Well,
and how is the role of mitophagy for strength training or for the growth of the aging muscles after resistance training? The mitochondria.
Mitophagy?
Mitophagy. Yeah.
Mitophagy is the normal mechanism to kill the aging mitochondria. Okay.
Yes.
The mitochondria inside the cell, when the mitochondria get bigger and bigger, it's going to age, right? And there you will be recognized by the mechanism to kill. This is what we call the mitophagy. The mitophagy is related to when the DNA of the mitochondria is not well repaired. Okay, so when the mitochondrial DNA is not well repaired, right? It's not well repaired, then it will stimulate the mechanism. And if there's too many mitochondrial damage, then it will further trigger inflammation. Mitophagy is when the damage can be handled by a cell. But if you have too many mitophagy, it will trigger inflammation later. So if you look at the very, very old people, you know, the DNA repair mechanism inside the cell is called PARP1, and that requires a lot of nicotinamide diphosphate. Okay, you need a lot of NAD+, right? So when the NAD+ is not sufficient amount inside the cell, then the mitochondria becoming unhealthy. The DNA repair became less, and the DNA of the mitochondria become unhealthy, and they will induce the mitophagy. And the mitophagy is further induce the inflammation. But it's not only localized in the skeletal muscle, it's localized in, like you said, that all muscle,
in every tissue.
All tissues. Yes, it's going to have that kind of phenomenon.
Yeah.
So you know a lot about muscle.
Because I'm practicing myself as a rule that we should not be frailty when our age is increasing, right? That is very that is a nightmare for me when I just become frailty. Therefore, I campaign also for my friends here, my physiology friends in Indonesia, that they do not do aerobic training, but also resistance training, because it will rejuvenate more than the aerobic training. But coming to the aerobic training, I have another last question, if I'm allowed to, with ginsenoside, RG1, you give to the people with strength training as well as aerobic training. But with strength training, is there any increase, right? Yeah, there is an increase in muscle growth and so on. But I read one paper I have in my collection. I read one paper that RG1 is only beneficial and can be absorbed and becoming beneficial for some people who are having certain type of bacteria in the gut. It is true, or I just read once one paper.
Okay.
So otherwise, it would not be very beneficial, something like that. And the maybe you can search as well in the internet. RG1,
Yes.
RG1 is only one phytochemical compound, right? And traditional Chinese medicine people would then say, "Oh, it is not enough RG1. It must be the whole herb, right? Ginseng,
Right.
Right. And there is another thing about this this special fungi from Nepal or from Himalaya. Caterpillar growth fungi. What is what kind of traditional Chinese herbs it is? I just forgot the name. It will increase also testosterone in our body and will increase also the muscle growth. It is true or not?
I don't know, but you bring a very important, you bring valuable point for me, that
oh yes,
because the RG1 is the steroid and there's sugar.
Yeah.
So you talk about some bacteria may be able to digest. So that is new for me. So I'm going to go back and read that to make the RG1 product better.
Maybe I can have your email and I can send you my PDF, right?
Sure. Yes. That's very good.
Yeah.
Yeah.
Thank you very much, Professor Wow, and
my pleasure.
谢谢，多谢。
Thank you. Thank you for your question.
Thank you very much. Yeah. Thank you, Dr. Titin as well. And for how long we have still our webinar?
So this is the time is question and answer. So actually until 3 p.m. So we actually have a long question because in here it's very interesting topic and maybe new in Indonesia.
True.
And we need to study about this, and maybe we will have a mentor from Professor Chia-Hua to study about this.
Yes.
Is it okay?
Sure.
And
Okay.
this maybe any other one asking about the RG1? Oh, Dr. Limpon Hoi, you want asking? Okay, please welcome Dr. Limpon Hoi.
Dr. Lim?
Yeah, thank you.
Hey, my good friend. Hey, good to see you again.
I was enjoying your talk so much. Thank you very much for sharing. All right. Since you're talking about the advantage of weightlifting or weight training or resistance training, All right. So that I think the terms like in the gym, always people put no pain, no gain. I think you can see everywhere, all the gyms that people put that no pain, no gain. I mean, that statement is actually a lot of people against that. But from your presentation, I think we actually support that. What do you think about this?
Well, this is a very good point. No pain, no gain.
Yeah.
Well, pain is one feature of information.
Yeah.
So we also understand that information is driving muscle growth. It makes your muscle younger. And therefore, when the muscle is younger, you have a higher potential to grow.
Yeah.
So this is very good point. Just enjoy the pain.
So, all right, another question maybe I just, because I was attracted to RG1.
Okay.
All right, the RG1 is actually, when you read a lot of paper, they talk about antioxidant defense. RG1 is actually antioxidant. So that what is the mechanism with the antioxidants with this, RG1 with this, what do you call it? Maybe you talk about semen cell. So what is the mechanism within these two? Yeah.
Okay. You are very often to hear the antioxidant.
Yeah.
There are two types of antioxidant. The first type is the antioxidant which can neutralize free radical. Okay, so that is one thing. And another antioxidant is actually a signal that can trigger inflammation to renew your tissues.
Okay.
So you need to understand that if you look at the cell, age cell and young cell, the age cell is going to have a more oxidative oxygen ROS, reactive oxygen species, produce more in age cell. The young cell are going to be less. So the ROS level is more related to the percentage of the old cell. Okay, so if you have the supplementation, which is going to lower your age cell in the tissues, then you will see at very beginning you are going to have the high free radical, and later on you are going to have a very low free radical. The reason at beginning you have the high free radical is because the free radical is coming from phagocytosis, and that is the first step of the inflammation. Okay, but later on, when the entire tissues is renewed, then you are going to have a low oxidative stress because every cell in your tissues are young, so it's going to have the low oxidative stress. So when we talk about a term like antioxidant, we need to be very careful. Are you talking about the things that is going to neutralize your free radical, or the things that is going to induce your inflammation to clear your senescent cell? But I believe the RG1 is belong to the second class.
Okay, I'm done. Thank you very much.
Thank you for your question.
You have a fun now. What of you here is good. And so any other question again from Moriarty? Moriarty, you here? You are asking directly, Moriarty.
My internet is unavailable, Mom.
Okay, so I will help her. He asking about what kind of exercise to prevent senescent cell in muscle tissue after exercise.
Well, high intensity exercise.
High intensity exercise.
Yeah. Moderate intensity exercise doesn't work.
And how long the time?
If you do 10 minutes, let's give you example that we have already done here. 10 minutes exercise, moderate intensity is not going to lower your senescent cell. But if you do high intensity, it's going to be very effective.
Okay, just only 10 minutes.
10 minutes, and the same energy expenditure.
Mm-hmm.
You don't want to use moderate intensity.
Okay, that's good. This is
you want to
like...
learn. You want to learn the weight training from Dr. Lin.
Mm-hmm. Dr. Lin Guanho, yeah,
Yes.
for weight training. Okay.
See the muscle.
So how about if injury is can that you giving stem cell injection?
Well, stem cell has been used for many treatment, but local treatment is the best. Because if you have a systemic treatment, you inject the stem cell into the blood. The stem cell is not going to localize into the healthy cell population. And also the oxygen is going to kill the stem cell. So if you have a very good circulation, you inject the stem cell, it doesn't work. So when you have the damage, muscle tissues damage or all sort of damage, it has been demonstrated it can accelerate the recovery for the young people. But for old people, you know, the data is more controversial.
Okay, thank you, Professor Pro. So, Professor Sugianto, you are asking something? Professor Setia Rahayu? Okay, so in here actually have Professor Ermati Ilyas, the Chief of Association Physiology Indonesia.
Hello.
Hi.
Okay, Mr. Wijaja.
Hi, Professor.
Okay. Welcome. You can ask him directly.
Hi, Professor Wijaja. Hi.
No, I'm a doctor. I'm a neurologist.
Oh, doctor. Okay.
Yes. I have a patient that I'm sure that you have a lot of experience that treating a patient with the stem cell in Taiwan, and he asked me about treating the chronic myelomonocytic leukemia with giving the stem cell. Maybe you have an opinion about treating that?
Oh, well, I don't have any experience with patient, so I cannot answer the question. Leukemia, by the way, leukemia is like all other cancer. The cancer, I do study some of the cancer in my research. The cancer is actually the random genetic mutation. So if you ask the cancer, even the same leukemia, you can probably have the mutation on different side of the gene. So I don't really have knowledge to answer your question on this.
Okay, never mind. Maybe you can give the contact person in Taiwan that using stem cell for treating the leukemia.
Okay. I heard that. Yeah.
Yes. Yeah. Like Dr. Agus, maybe you can give me your email address so we can contact with you.
Sure. Yes. Yeah.
Okay, thank you, Mr. Kwok.
Yeah, my pleasure. Yes.
Okay. Okay, it's very interesting topic. Actually, I remember last time before I come back to Indonesia, you said that in human, that all higher age have like cancer, like in the skin. You saw in here.
Oh, okay.
The blood, the.
Yes.
So it can be released with the stem cell.
Well, one of the reasons we're going to have a cancer later, you know, cancer has higher incidence when age is above 40. Okay.
Okay.
If you look at the body weight, if you look at the body weight, you found that age 40, the body weight are still increasing.
Yes, yes.
Okay, and people epidemiological study already found that the growth rate in weight are proportional to the incidence of tumorigenesis. This is well studied, okay, and well proved. Okay, and you also see if I'm going to show you the slide, then you will see that. Okay, let me show you this. The main driver for cancer, for tumorigenesis, is actually what we call systemic persistent inflammation.
Inflammation,
right? Yeah, the persistent systemic inflammation. Okay, let me give you the idea right here. This is very important for you to understand. Okay, so this is the yeast, right? Become multicellular and cell number increasing. When cell number increasing to a certain extent, you start to have increased cell death, right? Okay?
Yes.
The entire body, all over the body, you have 2% to 3% cell death when you are growing bigger and bigger. And this is going to have a huge consequences to mobilize your immune system, okay? You know, the most potent stimulator for inflammation is cell death, okay? So if you are growing bigger and bigger to a certain extent, you start to have the inflammation not only in the places that has the cell proliferation, it's all over the body, right? So you are going to have all over the body, you have the inflammation. So that is going to cause one thing. If tissues A demand the immune system, the tissues B is going to have the deficiency in the immune system, right? And you keep in mind the immune system would eliminate your senescent cell, right? So if I renew one side, if I renew the tissues A, and I cannot renew tissues B, then tissues B are going to be aged, right?
Yes.
And when tissues B going to age, it's also going to demand more inflammation. So you eventually develop the scenario that every single tissues in your body are competing for immune cell, right? So when this kind of scenario happen, then you are going to have somewhere to have a fast cell proliferation. You know, inflammation is going to trigger cell regeneration, right? And the cell regeneration, if it is higher, in this case, if you look at this graph, the cell regeneration can increase from the bottom to the top. It could be 200-fold, right? So if you have a lot of cell regeneration, let's assume every 100,000 cells, you have one mutation. Then you are generating a lot of mutation in human body, right? So growing bigger and bigger is the cause of tumorigenesis. So you want to keep your body not to generate more cell when you reach age 30. So that is my recommendation. And keep in mind, the diet and exercise are very important, because exercise is going to help you to kill the senescent cell, and therefore you don't have the systemic inflammation, not that much. And the diet, especially protein. If you have the protein, it's going to promote growth, right? The cell proliferation require DNA synthesis, and the DNA is going to require a lot of nitrogen source, right? And from your diet, only amino acid can provide nitrogen source. The carbohydrate and fat cannot provide nitrogen source, only amino acid. So when you are eating a lot of amino acid, when you are high body weight, that is going to promote a lot of growth, and you are going to have a more systemic inflammation, and it's going to increase your cancer mortality by about 300 to 400% if you are eating your protein about 15 or 20% in your diet.
Oh my God. So what is the best nutrition intake to eat? We have to more healthy and more younger.
Okay, when you are growing,
Mm-hmm.
right? When you are growing, when you are teenager, you can have high protein, no problem. You're growing. But when you are growing to a certain height, you want to adopt low protein. Because when you are growing bigger, the protein is going to help you to cell proliferation, right? Cell proliferation requires DNA, and DNA requires amino acid, right? So if you are keep eating a lot of protein, you are growing bigger and bigger and bigger, and eventually get cancer. Okay, so that is already published. Already 2014, 6 years ago, there's a one paper published in Cell Metabolism. It also showed that the daily recommended value of the United States is about 13%, right? It's between 10 to 20% protein, right? But if you look at the mortality rate, that kind of mortality rate, that kind of protein content is going to give you 37% higher mortality rate compared to someone who has only 10% or less of protein in their diet. If you eat 20% protein or more, it's going to give you about 400% increase in the cancer mortality rate.
Thank you, Professor. Oh, it's very clear. Okay. Hello.
Hello, good to see you again.
Yes. Okay. So,
Professor Amita.
yeah. Okay. So welcome, Professor Amita. You are asking directly to Professor Prof.
I'm sorry, I just joined very late. Yeah, because I have a discussion with the postgraduate student also at the same time.
Okay. Are you in Jakarta?
Actually, very nice, information. But yeah, I just heard the discussion. Yeah, very interesting topic for all of us, I think. And then you are the expert.
Makasih.
Oh, that's good.
How are you?
Good. The weather is very nice in Taipei. I hope you can come.
And no COVID in Taipei, huh? Very good.
Right.
Yeah.
I will be your host if you are coming. Anytime.
But we are dangerous for you. We will bring the virus.
I'm okay. I'm okay.
Because
nice to meet you again. Thank you, Dr. Titin.
Thank you, Professor Amita Elias. And this is for the last question for Oppa or Oppo A9 2020.
Oh.
Hello, Dr. Agus.
Oh, Dr. Agus. Oh yeah. This is from you. Oh yeah.
I'm here. Yeah.
Already.
I'm here again. Thank you very much for the opportunity. I'm so very Pavel. Very Pavel. I just forgot the name of the TCM.
Okay.
Yeah.
Okay. Thank you very much.
Yeah. Hello.
Yeah.
Yes, we can hear.
Yeah, you can. Cordyceps sinensis, Professor Kwok.
I'm so sorry, I will turn off your video because there is a network difficulty on you.
Oh.
Okay, just say it.
Okay. Bisa langsung ngomong aja, Prof.
Yeah. Cordyceps sinensis is the name of the TCM herbal. Can it increase our muscle growth?
I don't know. Actually, I'm I just got a project which is study the cordyceps right now.
Oh, yeah.
And,
very nice.
Yes, yes.
Yeah. It can increase testosterone. It is a mythology or something.
Oh, really?
Yeah, that's
true.
for old people, huh?
Yes, for old people. Yes,
Yeah.
Dr. Abita. That's right.
Yeah.
That's interesting.
And yes, it's very expensive here in Indonesia.
Yeah, even in Singapore.
Even in Singapore, right?
Okay, good.
You don't have experience with your study.
Well,
about
I do have.
sinensis.
I do have study on. Actually, it's a mixed formula. The cordyceps and rhodiola mixed together is a formula. But only one paper, so I cannot really give you much information. And actually, I just got a funding to study cordyceps right now, which is the joint fund by the government and one company in the United States.
Yes, I'm interested for, because old men or old people can do resistance training quite often, but if the testosterone level is low, the muscle will not grow. I think it is true. Therefore, I need cordyceps, because testosterone injection is also very risky.
Yeah, that's true. I think the testosterone are very important for elderly because, you know, age after 50, the testosterone is going
down.
Free testosterone, free testosterone is already going down, but total testosterone doesn't change. So you don't feel that total testosterone is declining, but the free testosterone is already been very, very low.
Very, very low. Yeah.
Yes.
Therefore, we need that.
Yes.
Okay, thank you very much, Professor Kuo, and nice. I enjoy very much.
Yes, me too. Nice to meet you. Yeah.
Nice to meet you. Thank you very much. Yeah.
Thank you.
Thank you, Dr. Titin.
Okay, thank you, Dr. Agus Budi, Dr. Professor Emita Ilyas, and also in here still have Professor Sugianto, Professor Setia Rahayu, and Professor Lim Bon Hui, that always accompany us to grow up together. And okay, maybe this is the last minute. And so very interesting topic about the stem cell. Maybe from physiology, or will be have will be have together collaboration together to study.
Sure. Yes, of course.
Yeah, it must be encouraged stem cell.
Yeah.
Research. Yeah.
And because in exercise also very needed, right?
Yes.
Right.
And
make the group
quite crucial.
Yes. So is it okay if we want to make a group to study about that, Professor Kuo, and you are to be the mentor and supervisor about that?
Of course.
And Professor Kuo also have a product that I remember last time you just give to my dean and Dr. Setia Rahayu. It's very good product. You say make younger, right? Is this from RG1 or from deep ocean mineral water? That last time.
I don't know. You got too many products. I don't know which one.
Yeah, make you younger. All of us want that one.
Younger, healthy,
the
and
young,
happy.
make you younger one. Okay. RG1 is very effective.
We need that one.
Okay. So thank you very much, Professor Kuo. That's very interesting topic, and you are very kindly that want to share your information to us, your knowledge to us, and this is very helpful for Indonesian people to study about that.
Yes.
And Professor Sugianto, you wanna have the closing statement? Okay.
Hi, Professor.
Yeah. So Professor Sugianto is the chief of physical education in here for doctoral program
Okay,
study.
good. Yes.
And Dr. Hayu is on magister program on spot also.
Okay.
Okay. Okay.
Oh, good to see you again.
So can we take a picture before we leave?
Sure. Yes.
Okay. Mr. Madi, would you help us to taking picture? Okay. So please cheers. I'm not see all of you. Where are you? Okay.
My video is mute.
Okay, you can open your video.
Thank you very much.
Okay.
Hi.
Oh, please, can you open the video?
Okay. Oh.
San.
San.
Ya, 1, 2, 3. Wait a minute. One more. San. Okay. You got it, Mr. Meldy? Okay. So before have a 130 people, now just 85. One more. San. That's good. So this is already four slides, right? And then this. Okay, so this is just for report. Okay, thank you very much. And so we must, actually we want to study more, but because the time is already closed, already finished, so let's we close. Thanks to Allah. So Alhamdulillah, we are already finished this lecture, and we hope that Professor Ko still want to be guiding us to study about that.
Sure.
Yeah.
Yes, my pleasure.
So, thank you, and
Take
see
care,
you
all
for
of
at the
you.
lecture. See you next time in.
See you.
Terima kasih.
Matur nuwun. Kamsya.
Kamsya.
Terima kasih Dr. Titin.
Terima kasih.
Terima kasih Dr.
Bu
Titin.
Terima kasih semuanya.
Terima kasih Prof.
Ya.
Chia-Hua dan Prof. Sugianto. Terima kasih. Yuk Dr. Agus.
Ya, makasih Bu Elmita, Dr.
Denny
Agus.
ada.
Sama-sama.
Ya, Dr. Denny ada dari UGM tadi.
Ya, makasih. Sampai ketemu lagi. Selamat sore semua.
Selamat sore semua. Salam sehat.